So as I was saying, I'm gonna talk about some tools for measuring React performance. So the first one is React Developer Tools, which is available in most of the browsers. The second one that I'm going to use is Chrome Developer Tools, exactly in the Performance tab. I know this window tends to be very intimidating, but we are going to work just with the yellow section, which is the scripting section. For React 15, we are going to work with React Perf, which is a library or a package that helps us to identify some waste elements and components that have been rendered. To use it, we need to just install the package and add a couple of lines, and that's it. We will see it in a bit. For React 16, we are going to use React Performance Devtool, which has a very nice user-friendly user interface. And the same, we need to install the package, and we have to add a couple of lines, and that's it. The guy that developed this application or this tool, it's very friendly, and very supportive. So if you use this tool and you have any issue, do not hesitate in report the bug. So I'll prepare a small application here, which is just render cryptocurrencies more than 1,000, and it changes the color. So it's very simple. Now, in terms of the application itself, we are going to have this is the data, nothing complicated there. In this case, this is in React 15. This application is using React 15. So I just add these two lines. In my packages, I'm just adding the React add-ons perf. And in the application itself, I have these two lines that help me to expose the window. We keep track of the performance. We have a manager here, and this manager just has a select and a list of coins. Then this list of coins, when we click in one of the coins, it will be deleted from the list, so it doesn't have any complication there. And we have a coin, which in reality is just a simple button, and that's it with the style. So sorry for the comments, but I need to keep track of what am I gonna talk so I don't forget, but in reality this component is very simple. So let's see how this application, intentionally I left some bad practices, so I set some examples. So let's see how this little application does with the performance. So I'm going to use, as I said, the performance. I'm going to make it the CPU slow. So to make it slow, I'm going to put it here. And I'm going to add the /React Perf. So this React Perf helps me to, when we see the performance, we will see when it's mounting, when it's updating, when it's rendering. So we keep track of more information about what's actually happening. Now I'm going to record, I'm going to delete one coin, and I'm going to stop. And then we will see. As we can see here, this list of coins, that's what we have. But then I will try to zoom in here. Oops. So zooming in here, I can see that all of these little ones are all the coins that have been updated. Do we really need to update the coins? Not really, because they are not changing any properties. So that's what we need to improve. The moment I'm using this with the tool, with the Chrome tools, but we can do the same with the perf. This is the extension. We can use the waste, DOM, inclusive or exclusive. These 4 elements, print operations, shows the DOM manipulations made. So we want in this list just the components we are working with. So we don't want more than that. Print wasted are the times we spent on components that were rendered stay the same. So there are components that the properties didn't change, the state didn't change, but for some reason they are being re-rendered. So we need to keep, and we ideally, in our applications, we want this list to be empty. And I'm not going to talk about the times too much, the print inclusive and print exclusive, but the only difference is that in the print exclusive, we are going to exclude the mount components, so the time that the component takes to mount and processing some props. So now that I mentioned that, I'm going to refresh this again. So I'm going to remove this. I'm going to refresh the page. That is taking a lot of time. Now I'm going to start. I'm going to delete this coin. I'm going to stop. And as you can see, we have all these elements rendered on the DOM. No wonder why the application is too slow. So, well, what is happening here is definitely related to our keys. So if we go back to the coin, let's fix that by going to the list. When we have a list, we should add a key to every element, but I am adding it as an index. So because it's an index, every time we delete a coin, if we go back here, every time this is 0, 1, 2, 3, 4, so on. If I delete 1, the index moves and this becomes 1. So when we do the reconciliation of the tree, so when we have the virtual DOM and the actual DOM, it's not the same, because it's like, well, there's no 1, there's no 2, because now the 1 was the previous one. So that's why this is happening. So to avoid that problem with the reconciliation, we're going to go back here and we're going to give him a unique ID, a truly unique ID. So I'm going to save. I'm going to go back. It's refreshing. Now I'm going to refresh it again because I am paranoid. And then I am going to start. I'm going to delete the coin and I'm going to stop. And as we can see now, there are no extra DOM manipulations. We just have one, which is the operation move. The operation done is remove a child, which is okay. But now we have another problem. The problem is that we have print wasted. And as I mentioned before, print wasted are all these elements that have been re-rendered, but nothing has changed. Why is it rendered in the instance count column? We are rendering 1186, but we didn't change anything in there. So then how to fix that? Well, to fix that re-rendering, we need to make use of the lifecycle events. So we have two options here, whether we play with the should component update, and by default should component update returns true always, and that's why it's always rendering again. If we turn it to be lazy and it's like, oh well, let's just put return false, the DOM is not going to be comparing the actual elements and it's going to do crazy things. So the proper thing to do is to compare the state. Actually, this is probably not even the best option. The best option would be to compare the properties that we know that are going to change. If the color is going to change, so just compare next properties, the color with the new properties. But for the purpose of this exercise, I'm just going to compare the next state with the new state and the next properties with these properties. If they change, then do the update. If not, don't do the update. So I'm just going to do that, save, and I'm going to go back to my rendering. I'm going to refresh. It's going to take a while. And now I'm going to start, delete one coin, and stop. And the print wasted has disappeared. It means it's not being rendering. And if you notice, it's slightly quicker. Let's do it again. So actually, it's quicker. Like, we cannot see that delay, despite the fact that we still have the CPU slowdown. So if I put it obviously normal, it's gonna be super quick. So I really recommend you to slow down when you are going to test your performance. Slow down the CPU so you get a better situation and you notice when is it slow. So now let's try to do this. Now this is with React 16. As I said before, I recommend you to use whether should component update or pure actually I did the should component update, but what I can do even probably better, if you know that this is going to be a pure component, is just to set it up as pure component. And the only difference between a component and the pure component is that in the pure component you don't have access to the should component update, but you still have access to the lifecycle event. So it will still do the same if I do pure component and I go back to my application, I refresh, I go to perf. By the way, for the people that don't use Chrome, this extension, as I said, is just available in Firefox and Chrome. But if you don't use those browsers, you can just do here in the console, as long as you add the lines that I mentioned. You can do here in the console line perf.start, then you do the action, which I'm going to delete the coin, and then I'm going to put perf.stop, and then perf.print operations or wasted. So in this case, I'm going to print both. So operations first, should be just one, and then perf.print wasted. Stop, and we don't have anything wasted. So now that's with React 15. Let's do the same with React 16, but the only difference, the application is the same. The only difference is going to be the tool that we will be using to test the performance. In this case, we are using React Perf Devtool here, and just for the purposes of this talk, I'm adding this in the documentation. It's mentioned, so you need to install this one to do more with the performance. So if you want to get that performance, send emails or put it into your Google Analytics, well, then you need to set up this little server, and I'm doing it now, just to simplify. Although at the moment I'm just using console log, and probably I wouldn't need it, but I'm just setting it up there. So the application is the same. Now this is the one that is in React 16, is the same, but here we are going to use this other tool. So I know, developer tools, and here we are in React Performance. This is the tool that we use in React 16. As you can see, it has a better user interface. Now I'm going to delete one coin, and I'm going to clear, sorry, and I'm going to delete one coin. And as we can see, we have all these, actually, let me refresh again, because we need to see all the life cycles. I'm gonna clear to delete this one, and we can see here that we are calling 1100 cycles, which it's not what we want. So once again, quickly, we need to fix the issue by setting a proper key, which is the coin ID. Save, and then in the coins, let's make this a pure component. Okay, save. Now we come back, refresh. Let's make this one with the performance. So here again, I'm going to slow down the CPU, and I already refreshed. I'm gonna start, I'm gonna delete one coin, I'm gonna stop, and as you can see now, here you have the reconciliation tree and the list, and we don't have all the coins that we were seeing at the beginning of the talk, that we were seeing every time it was updating. So that's one of the ways. Now there's, apart from making sure that we set correct keys and use pure components or correctly the should component update, another tip would be to, another good practice would be not to avoid inline styles. I actually tried to make a couple of tests using a class name, inline styles, or style components. I didn't really notice the difference, but I noticed that if I do something wrong in the styles, definitely it loads more. So I'm gonna show that at the moment. So I'm going to demonstrate that, I'm going to use style components. So instead of having an inline style, I'm going to use style components, and I have here the code for my button. So I'm just gonna put here. Oh, going to uncomment this, which is just a coin. Sorry, it's just a style, nothing complicated. It passes up a property color, and based on that color, it renders the background. And I need to add this attribute instead of my inline, inline style. Copy, and then here instead of instead of this style, I add the color, and instead of the button, it's going to be a coin box. Save. Now let's go back to our performance tools, and I'm going to use the React Performance, which is for 16, but I prefer to use it in console. So let's refresh. Let's delete one. Is this the one? Oh, I actually wanted to see. So this one, the time, this total time 8,500 compared with the previous one that was around 100, it's massive just for one simple change. So the only thing that I want to put as an example is that we can use the correct tools. I'm not saying style components is bad. Of course no. I'm just saying that we can have the correct tools, but if we don't use them properly, we can cause some performance issues. So as I said, I try to compare the times between using class name or using the style or style components, and I didn't notice too much difference, and I didn't have too much time to do more research into how the actual virtual DOM is comparing that. But I read that everywhere that using inline styles is not a very good practice. Actually, I forgot to mention this tool as well. The React developer tools, for instance, I'm going to use this React, has this option, very handy, highlight updates. So when you highlight updates, I'm going to delete it, you will see quickly a blue frame and the other a blue frame in the coin that I'm deleting. And that React developer tool is telling us those elements, those components have been updated. So that's another way to know which components have been updated. So we have definitely different tools. Apart from that, so the colors of the frames depend on how frequently those components have been updated. If it's blue, it's less frequent, but if it's red, it means that component is rendered quite frequently. So apart from those tips that I said about avoiding inline styles, using keys, PureComponent, avoid using synchronous updates in componentWillMount. So imagine this component, this list of cryptocurrencies have been loaded from the back end. If I put it in componentWillMount, it means that I will wait until these coins load, and then I'm going to mount the component. So I better move it to another method, component did mount instead of will mount. And also use routing to decouple the application and just load the parts that I really need. You can find this code in my Git repository, and that's it.
Hey, so you mentioned you should avoid doing anything synchronous in componentWillMount. Why would you use componentWillMount to begin with?
Well, actually,
component did mount.
You shouldn't use componentWillMount. You should use component did mount. Did I say it like that? Did you?
Yeah, generally, why would you use componentWillMount in the first place?
Yeah, actually, there are no many uses of componentWillMount. For what I read, there are not so many uses of that method. So you can use usually should component update, did mount, or there is one use for componentWillMount, which is binding events. Sometimes you can bind events in that method, but other than that, there's no point to use that lifecycle.
It's also going to be deprecated.
Yeah, I guess. Because anyway, the event that you can bind, the event that you can bind in willMount could be in the constructor. So there's no point. Actually, a lot of people put it in the constructor, so then there's no point to put it in the willMount.
Thank you so much.
Thanks.